always be locked in this class. All right, everybody should be looking at page 4 of the 6.3 note packet, which kind of it looks vaguely like this, except yours probably didn't print crooked like my PDF is. Yeah? Okay, so today we're talking about composite functions, which means that we're going to use one function as the input for another function. It's a function inside of a function. And we're going to practice evaluating composite functions where one of the two functions is a regular trig function, sine, cos, or tan. The other is an inverse trig function, inverse sine, inverse cos, inverse tan. Yeah. And first we're focused up here, this little top blurb of 6 statements, on the domain, the allowed values for input into these nested functions. And you'll notice there's a left side, there's a right side. There's some differences between the left side and the right side. So take a second, compare left side to right side. What differences do we see? What differences do we see? I'll give you just a second, chat with your neighbors. What differences do we see? Not quite related to what we're talking about, but yes. Sometime today, pass. There you go. All right. So let's start. Do I have a volunteer who can tell me some differences that they see between the left and the right? Differences. What's different?
One has pi.
So this guy's the only one that has a whole pi. Okay, good. What else do we see? There's pi's over here. There's not pi's over there. That's a good noticing. Pi's and not pi's. Yeah, what else do we see? The inverse location is different. Yeah, so on the left side, the inverse is the inside function. On the right side, the inverse is the outside function. Yeah. So the location of the inverse. Very good. There is a connection between the inside function and the domain that's tied to it. We're going to start with the stuff in red. We're going to start on the right side. When we started talking about inverse functions, beginning of 6.3, very first set of notes, and we talked about taking a function like sine, which is a wave, and tilting it sideways to make an inverse. We said we couldn't just take the whole sine wave, because if I did that, I'd have something that did this, which is not a function. Yeah? So we had to put limits on where sine was allowed to exist. Does anybody remember what the limits on the sine function were? Beginning of 6.3, what limits did we put on the sine function? I hear some shuffling through notes. That's a good thing. Sine. Negative pi over 2 and pi over 2, yeah. These numbers here, this domain, is tied to the domain of the inside function. Sine's limits, when we talk about sines and inverse sines, is for minus pi over 2 to pi over 2. Good. Cosine, when we limited it to 0 to pi. Yeah? Tangent, when we limited it, it was limited between its first asymptote on the left and first asymptote on the right, which was negative pi over 2, pi over 2. Yeah. On the left side, the inner function is the inverse function. And the domain of sine inverse is the range of sine, -1 to 1. Same for cos. The domain for cos inverse is the range of cos, -1 to 1. Same for tangent. The domain for tan inverse is the output for tangent, -infinity to infinity. So when we're evaluating these, we want to make sure that whatever that x value is, it falls in the domain for that inside function. That's really the big check here. If it doesn't, we have to find another angle that gives us an equivalent output. Yeah? And we're going to practice that. Yeah? We're going to focus over here because this one is easy to fix. Yeah? This guy is a little bit more difficult to fix, and here's why. When I look at this side, sin, cos, and tan take an angle and spit out a side length, yeah? Take an angle, spit out a fraction. Sine inverse takes a side length, spits out an angle. So the inside function is going to spit out an angle. The outside function takes that angle and spits out a side length. This here, these guys, are side lengths. A ratio of side lengths, right? Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Yeah? They're those fractions in the ordered pairs in the unit circle. On this side, the red side, sine takes an angle and spits out a pair of side lengths, right, a fraction. Inverse sine takes that fraction and spits back out an angle, meaning my final answer here is an angle. My input was an angle, my output was an angle. Yeah. It's easier for us to find buddies with this guy. This is the one we're going to focus on today. Yeah? Yes? You may. Did you make any hall pass? Okay. So, the process, pretty straightforward. If, we're in the how-to, yeah? If the angle is in the domain of the inside function f, then the answer is just the angle that we were inputting to begin with. F inverse of f of theta is just theta. Sine inverse undoes sine, gives us the angle, right? Cos inverse undoes cos, gives us the angle. If the input angle theta is not in the domain for cos, if it falls outside of 0 and pi, right? For sine, if it's bigger than half pi, smaller than negative half pi. I need to find a different angle, a new angle, that has the same answer as the original function, the original cos, the original sine. So we're going to find a new angle inside the domain that produces the same output. F of theta is f of the new angle. They give me the same answer. In that case, the answer is the new angle instead of the old angle. So if theta is in the domain, the answer is just theta. If theta is outside the domain, I'm going to find his buddy that's inside the domain, and that's the answer. Which is why we have to understand the unit circle. And we're going to practice. We're going to do a whole bunch of these, yeah? Are we ready? Okay, we're going to draw some unit circles. They're going to be quick and ugly. I would encourage you to do this on your notes. I would encourage you to do this on scratch paper while you're doing your Delta Math homework. Yeah, being able to quickly draw a unit circle and figure out where your angle is sitting relative to where we want it to be is a really helpful skill. Okay, so example, evaluate the following. A says sine inverse of sine of pi over 3. So first thing I'm going to do is draw a unit circle. Not pretty, yeah, it doesn't have to be. 0, this right here would be pi over 2. That's a whole pi. This is positive side, it's 3 pi over 2, but I know I want negative. That's negative pi over 2 coming down the other side. And I'm going to look at the inside function. Inside function is sine. What are the limits on sine? Check the top. Very good. I got it in stereo. Negative pi over 2 to pi over 2. Quadrant 4 and quadrant 1. I need my angle to be in that red zone. So we're going to grab our angle, which is pi over 3. We're going to plot an angle of pi over 3. Start positive x. Positive means go counterclockwise. Pi over 3, is that bigger than pi over 2 or smaller? Bigger or smaller? Give me a thumbs. Pi over 3, bigger than pi over 2, smaller? I see a whole bunch of thumbs down. I agree, it's just a little bit smaller. So pi over 3 would be here. Is that in the red zone? Yay, yes it is. Which means my answer is just that angle. Yeah. Oh yeah. The only time it's not is when we fall outside that red zone. And that's only one extra step, yeah? If you're familiar with the unit circle, this isn't bad. So I would encourage you, until you've got a mental image of the unit circle, have it out while you're doing your homework, yeah? All right, try another one, yeah? I'm going to redraw just so we have a clean surface. Whoops, not minus pi. I mean, technically, yes, but not what I wanted. Okay. B says sine inverse of sine of 2 pi over 3. Come over here. Original function sine, same domain as last time. Minus pi over 2 all the way up to pi over 2. Yeah? Same as last time. And we're going to plot the angle that they gave us. 2 pi over 3. Bigger than pi over 2 or smaller than pi over 2? I see a couple thumbs up. Yeah, just a little bit bigger than half pi. So the angle that I have is right here. That makes me unhappy. That's not in the red zone. I need to find a point with the same sine value, the same y value. So I'm going to, do exactly what Daniel is suggesting. I'm going to flip the picture. I'm going to flip the half that's not shaded onto the side that's shaded. And I'm going to get a reflection that's right here. That's his reflected buddy, yeah? And the question is, what angle goes with that point? Pi over 3, yeah. That's pi over 3, which means my answer is pi over 3. because sine of 2 pi over 3 is equal to sine of pi over 3. And I need to use the angle that exists in the red zone. So I'm using pi over 3 instead of his reflection at 2 pi over 3. Yeah. That's it. That's all we're doing. Yeah? The next two are cosine. I'm going to set up the unit circle, and I'm going to give you a couple minutes in your small group to try the cosine ones. Yeah? So for both of the next ones, we're looking at cosine. Yeah? What are the domain limits on cosine? Cosine's the odd one. Sine and tan have the same. Cos has what? 0 and pi, yeah. So cos needs to be up here. Yeah? Good. Okay, I'm going to pop a couple minutes on the clock. You're trying the two cosine ones in your small group. All right, let's come back. We're looking at C, cos inverse of cos of 2 pi over 3. Can somebody tell me which quadrant 2 pi over 3 sits in? Where is that sitting? Quadrant 1, quadrant 2, quadrant 3, quadrant 4? 1, 2, 3, 4. Which quadrant? 2. Yeah. 2 pi. We already saw 2 pi over 3 earlier, right? He's over here. Is that in the shaded area? Yes. Yeah. And I saw most of you got that, which is happy face. Perfect. Okay, I'll use a different color for the next one because I don't want to have to erase and redraw. Negative pi over 3. When we measure angles, we always start positive x. What does the negative sign tell me? Which way do I go, down or up? Down, yeah, because normally we start here, go up, right? Positive is counterclockwise, so negative is clockwise. So 1/6, 1/4, 1/3. I'm down here. Negative pi over 3. Does that put me in red zone? No, sad face. Not in the red zone. So I have to take the shaded half and the unshaded half and map them onto each other. I have to flip, meaning I go straight up, and that puts me here. Where is that? Pi over 3. If you fold your bottom half onto your top half, yeah, it's going to map right onto pi over 3. So our answer is pi over 3. Yeah. That's half the homework right there. Yeah, easy peasy. We got this. We got this. Yeah? Similar idea for the side lengths. Exact same process. Yeah? Good. So we know how to handle sine inverse of sine and sine of sine inverse. They undo each other. What happens when we get sine inverse of cos? Ugh. Yeah, the shrug. I saw the shrug. We don't know. Let's look at the graphs of sine and cos and see if we can't figure it out. So I'm going to scoot this over a little bit. So here is the coordinate plane. I'm going to start with sine. Does sine start at 0 or 1? 0. Sine starts at 0. So my sine function starts here, goes up, comes down. 0, pi, 2 pi. Yeah. And we'll do cos in blue. If sine starts at 0, cos must be the one that starts at a 1. He starts at a peak. Yeah. Comes down, goes back up. And his intercepts are at pi over 2 and 3 pi over 2. Those shapes are the same shape. They're both an up cycle and then a down cycle. They've just been shifted. Sine and cosine map the same thing. They're just starting at different points along that wave. The question is, how far apart are those waves? Yeah, I heard it mumbled. Yeah, they've been shifted by pi over 2. Where sine has a 0, that's where cos has a peak. Where cos has a 0, that's where sine has a peak. They're shifted by half a pi. Which means when I take sine inverse of cos, or cos inverse of sine, whatever angle was the input, I have to shift it by pi over 2. Because sine and cos don't line up. I have to shift. Yeah? That's the only change. So let's look at the process. Yeah? Deep breath. I'm going to scooch you back over because we've seen those graphs. So the reminder is it's always the inside function that determines your domain. So if we are looking at sine inverse of cos, the domain of cos is the thing I'm worried about. If I'm looking at cos inverse of sine, sine's the inside guy, sine's domain is the one I'm worried about. If my angle is in the appropriate domain, he's in whatever region is the inside function's domain, yeah? The answer is the angle shifted by pi over 2. Pi over 2 minus x. Pi over 2 minus x. We're taking the angle, we're shifting it by pi over 2. The question is, if my original x value is not in the appropriate domain, it's not in the shaded area of my unit circle, what should I do? And what did we just do on the top half of the paper? Find its buddy. Yeah. Yeah, we find our original angle, we find its buddy that is in the shaded area, and use that angle, which is exactly what we're going to do here. If it's not in the appropriate region, we find a new angle y that is in the appropriate region that matches, and then we just do pi over 2 minus the new angle instead of the old. Pi over 2 minus the new angle instead of the old. What that means is the first half of this type of problem, where it's sine and cos instead of sine and sine, starts the same. Look at the inside function. Look at the domain on the unit circle. Is the angle that you have in that domain or not? If not, find its buddy in the domain. The only difference is now that is not your answer. You have to subtract it from 2 pi to get your answer. One extra step. Let's try some. That was way noisier than I intended it to be. All right, so we got 2. First one is sine inverse of cos of 13 pi over 6. Ugh. So draw the unit circle. Look at the inside function. What is my inside function? It's cos. Cos is from 0 to pi in my shaded area. It's where I need my angle to be. If it's not, I have a problem. So, first question, probably an easy question to answer. Cos needs to be between 0 and pi. Is 13 pi over 6 bigger than pi, smaller than pi? Bigger. Quite a bit bigger, because 13 over 6 is more than 2 pi, actually. That's way too big. I need to be between 0 and pi. So let's look where 13 pi over 6 puts us, and then we'll figure out the corresponding buddy that's between 0 and pi. Yeah? So let's look at 13 pi over 6. How many times does 6 fit into 13? Twice. So this is 2 pi plus some leftover. 6 goes in twice. That leaves me with 13 minus 12, which is 1. It's going to leave me with 1 pi over 6. 2 pi is a full circle. So I'm starting here. I'm going all the way around, and then I'm going up another pi over 6. The first loop is the 2 pi. The extra bit is the pi over 6. So this is where that puts me. But that's too big an input. I'm not allowed to have 13 pi over 6 as my input. So the question is, what buddy goes with him? So if 2 pi is the full circle, how much extra above 2 pi did I have? Pi over 6. This must be pi over 6. Which means when I go to do my formula, I'm not using 13 pi over 6. I'm using pi over 6. So this is pi over 2 minus pi over 6. Yeah. And then you just simplify. And this is where people get sad because it's fraction math. Because remember that sine and cos don't match. These are not matching functions. Sine is shifted half a pi relative to cos. And so the pi over 2 is compensating for that shift. Right? The first functions we did were sine inverse of sine, cos inverse of cos. Now we're doing cos inverse of sine. They aren't the same function. And so this part here compensates for that difference between sine and cos. Okay, fraction math. If you could do it the traditional way, I know if I want to add or subtract fractions, they have to have the same denominator. I want to turn 2 into 6. What do I multiply by? 2 times what is 6? 3. Very good. Top and bottom by 3. That'll make this a 6. 3 pi minus 1 pi is 2 pi over 6. I should not leave it like that. Those are even numbers. It would be pi over 6 divided by 2 is 3. Happy face. Pi over 3. I agree. Sine inverse of cos of 13 pi over 6 is just pi over 3. Take the pi over 6, shift it by half a pi. Yeah. Oh, so I multiplied top and bottom by 3. This just became 3 pi. 2 times 3 became a 6 because I need the denominators to match. If you suck with fractions, that is okay. Fractions are hard, yeah? And you probably didn't learn about fractions recently, so you may have forgotten everything you knew. If the fractions scare you, take the pi out and just look at the numbers. So I would ignore the pi's. This would be a 1/2 minus a 1/6. That is something my calculator can do. You're going to plug this in your calculator, and you're going to press the math button, and you're going to choose 2 frac. What does the 2 frac command do? It takes a decimal, spits out a reduced fraction. You should try this on your calculator so you get the process down, but I would bet money that 1/2 minus 1/6, after you do the 2 frac, will spit out 1/3, because our answer is 1/3 pi. You should try that to make sure that's what you get. Yeah. So if the fractions scare you, remove the pi from the picture, do the fraction math on the calculator, and then slap pi back on your answer. And I see some people plugging on their calculator to check, which is good. Are we getting 1/3? Daniel's nodding yes. Looks like Alexis is nodding yes. Yeah, that does work. Yeah? So on your homework, when you're doing delta math and you encounter these, don't panic when you see fractions. Just grab your calculator. Yeah? It's 2025. We have tools to help us. All right. We got one more. One more, and then you should have about 10 minutes of homework time. Math frac. Math frac. Write it down. Math frac. All right, we're going to do B. Yeah, this was A. We're going to do B down here and draw my unit circle. That is the worst unit circle of the day. Frowny face. Pi over 2, pi minus pi over 2. B says cos inverse of sine of negative 11 pi over 4. What are my domain boundaries for sine? Very good. Quadrant 4 to quadrant 1. Perfect. That's my red zone. I need to figure out where negative 11 pi over 4 lands. And I'm going to do the same process. 11 pi over 4 is bigger than 2 pi, because 2 pi would be 8 pi over 4. So I'm going to reduce this to something I can do in my head. Yeah? So 11 pi over 4. 8 pi over 4 is 2 pi. So I know there is a 2 pi in here. 11 minus 8 is 3. I have 3 pi over 4 floating around. I'm ignoring the minus sign. I just know when I graph it, I go backwards. Yeah. When I graph it, I go backwards. Right now, I just want to know how much I'm going backwards. But that was a good question. So I know when I graph, I'm going to go clockwise instead of counterclockwise. Start at positive x, go clockwise like the hands on a clock would. 2 pi is a full circle, so I'm going to make a full complete loop, and then an additional 3 pi over 4. So I'm going to start here. I make a full loop, so I'm back on the x-axis. Another 3 pi over 4. 2 pi over 4 is here. 3 pi over 4 is here. So that is where negative 11 pi over 4 puts me. And we check, did we land in the red zone? Frowny face. So I need to go and find the buddy that is in the red zone. So I reflect from the left half to the right half. I go straight across. And I want to know where that is relative to the x-axis. What is that angle? Louder. Well, no, what was your first instinct, Brittany? No, you did. What did you say? 7 pi over 4 is the positive, so that's up and around. We want the complement to it. So 8 pi over 4 minus 7 pi over 4 would leave me with how many pi over 4s? 8 minus 7 is 1. Yeah, this is negative pi over 4. I can go 7 pi over 4 back forward or negative 1 pi over 4 backwards. Yeah. So the angle I'm using above when I do that pi over 2 minus x is negative pi over 4. So this is pi over 2 minus negative pi over 4. It worked earlier, now it doesn't work because my board hates me. Minus minus becomes plus. That makes me happy. Pi over 4 plus, no, pi over 2, sorry, plus pi over 4. I want to add those fractions. I need a common denominator. What do I multiply 2 by to change it to a 4? 2, top and bottom. 2 pi plus a pi gives me how many pi's? 3 pi's. This is 3 pi over 4. Yay. Process is the same as the top with the added step at the bottom of doing pi over 2 minus whatever your answer was. So if the inverse and the function match, just find the angle that's in the shaded zone. If the function and its inverse don't match, you have to do pi over 2 minus that angle in the shaded zone. Only change. You've got about 10 minutes of class time to practice in Delta Math. Yes? When I see you tomorrow, we're going to do more in class practice because this is hard. Yeah? Please use this class time wisely. I'm going to circulate answer questions. Let me pause the video.